Hello, in this video, I'll be going over the differences between a resonance structure and an isomer. To begin with, a resonance structure in general has the same molecular formula and the same arrangement of atoms, versus an isomer, which has the same molecular formula but a different arrangement of atoms. In this example, I drew out two structures. They have the same molecular formula and the same arrangement of atoms. So as you can see, we do have two alcohol groups, as well two oxygen and one center carbon. So on my left and the right, we can see that on the left side, there's two lone pairs. Versus on the right, there's three lone pairs. On the left side, we started off with a double bond. We gave a valence electron to that oxygen, so we're just moving electrons in resonance. On the right side, we received 7 in total electrons. And thus, we need to make it a negative sign in that oxygen because it has more than 6 valence electrons. On the left side as well, you can see that you had a single bond between the carbon and the oxygen, but on the right, we have that double bond actually. That's because one valence electron from that oxygen on the left was given to make a bond between the carbon and the oxygen, making it the double bond. And thus, this example represents a resonance structure. Same arrangement. Of atoms. Also, a side note, you should always be carrying the charge to resonance structure. Let's go over a second problem, but in this case I'll be talking about an isomer. So as you can see that we do have a CH3 group, which is bonded to carbon double bonded oxygen. On the right side here, we have an H hydrogen, which is bonded to that carbon to the double bonded oxygen. Also, visually, you can see that both structures have different orientation of atoms. Which concludes that it's an isomer. Thus, concludes that an isomer and a resonance structure have the same molecular formula, but different arrangement of atoms.